Alright, I'm going to do a quick lesson on similar triangles, and there's a few things that you should know. The first is that similar triangles work on the work off this idea that if you have a triangle, let's say we have something like this, and let's say I knew that. Well, let me redraw this. Let's say I have an isosceles triangle, and this is triangle ABC, and I have a perpendicular bisector. And because I knew the triangle was isosceles, I know that this angle is similar to this angle, and I know that angle BDA is congruent to angle BDC. So basically what I'm saying is I know that angle BAD is congruent to angle BCD, and I know that angle BDA is congruent to angle BDC. Now, because it's a triangle, if two of the angles are congruent, then the third pair of angles must be congruent as well. But all you need to prove that two triangles are similar is that you have an angle and another angle congruent to an angle and another angle. And this is enough for similarity. And here's the deal. Because those are similar, the sides that are similar work like this. AD is going to be similar to DC. BD is similar to BD, and AB is similar to BC. Now, none of this is earth-shattering, but it is important that you know that. And the reason why is because the two triangles are going to be proportional, and I'm going to get into that in a minute. And so I'm just going to erase this picture for 1 minute. And what I'm going to do is I'm going to draw another picture. And this one's a little bit different. Looks something like this. And here, I'm going to label these A, B, C, D. I'll call this point E. And let's say I knew that ABE was a right angle triangle and that angle ECD is a right angle. So I know those are both right angles. Because these are vertical angles here, this one and this one, vertical angles are congruent. So right now I have an angle congruent to an angle and another angle congruent to another angle. So my triangles are in fact similar, which means that triangle ABE is similar, that symbol means similar, to triangle. And watch the way I write this. I said ABE, and notice I went from this point down to the B to the E. So I'm going to say DCE. And it's because these points are the ones that are corresponding to the points on the other triangle. So if I said that this was 3, we'll say 3 centimeters, and I said that this was 9 centimeters, and that this was 10 centimeters. I might want to find out what's the value of EC. So there's a few things that we have to do here. And one of the things you can do is you can always break these into two separate triangles. And because you know that angle B corresponds with angle C and angle AEB corresponds with angle DEC, you could just redraw the picture and separate them. I don't really like doing this, but it does help. And I know that CD is 9. I know that AB is 3. I know that the hypotenuse here, AE, is 10. And I'm looking for EC, which is X. And now you might say, oh, wait a second. I didn't want to make that 10. Sorry. I want to make that 5. And you're allowed to do that when you're making the video. You know, change your numbers. And now what I'm going to say is, I know that that's X, and what I normally do is I'd say, well, 3 is to 9, and I'm going to say AB over DC. You know what? I'm going to actually do one other thing. I'm going to make up a little chart. I'm going to have triangle ABE and triangle DCE. And I have my altitude, I have my base, and in this instance I have hypotenuse. So my altitude for ABE is 3, my hypotenuse for ABE is 5, my altitude is 9, and I'm looking for my base here. I don't know what my base is here, but it doesn't really matter. What I do know is I need the rate of proportion, and I can't do that because I don't have enough pieces. So what I'm going to do is this. I'm going to use the Pythagorean theorem to find my base here, and it's going to be 3 squared plus a squared equals 5 squared. That's 9 plus a squared equals 25. Minus 9 minus 9. I get a squared equals 16. Take the square root of both, and you get a equals, technically you get a equals plus or minus 4, but you don't have to worry about the 4 being negative. And so my base is technically it's 4. Now take a look at this. These pieces are all in proportion. So now I can say 3 over 9 equals 4 over x. I'm going to cross multiply, and I get 3x equals 36. Divide by 3, and I get x equals 12. So this is going to be 12. And what you can also notice, and I hope you do, is, let me erase this, is this. Once I know that that's 12, take a look at the relationship here. 9 is 3 times larger than 3. 12 is 3 times larger than 4. So what do you think this is going to be? I'm hoping you said 15. Alright, so that's just an introduction into similar triangles, but it went a little bit longer than I was hoping. So I'm going to do one more video, and that's it.